The objective of today's lesson is for students to master and practice solving equations with factored or easily factorable expressions. So if you look at the do now, all of this should be familiar to you from our previous lessons on factoring. X squared minus 9 factors as x minus 3 times x plus 3. We factored that using dots, the difference of two squares. X squared minus 9x factors as x times x minus 9. We factor that using the GCF. Now, you'll notice the third do now is not a factor problem per se, but it's asking you to solve an equation. You'll remember from yesterday's lesson the zero product property, which means anything times 0 is equal to 0, that to solve this type of equation, we want to set it equal to 0. So x squared minus 9 equals 0. Well, how would I solve that? Looking back to our first do now, we know we can factor x squared minus 9. As such, we would set each one equal to 0 so that we arrive at our solutions of 3 and negative 3. Remember, whatever the highest exponent of the variable is, that is the number of solutions that we are expecting. So, let's take a look at the following. Sam takes the following approach to solving the equation x squared equals 9x. He says cleverly, oh, why don't I just divide each side by x and get my solution of 9? Well, is 9 a valid solution? Recall that to determine if any solution is valid, you substitute the number in for the variable to the original equation. Well, yes, 9 is a valid solution. But we said earlier that if the variable has an exponent of 2, we are expecting 2 solutions. Well, as we did in number 3 in the do now, we would subtract 9x from both sides to set it equal to 0, factor using the GCF, and now we see that we have 2 solutions. X is equal to 9 and x is equal to 0. So somehow the strategy that Sam used did not pick up as a solution 0. Well, why is that? Well, if you take a look at the steps that Sam underwent, he divided both sides by x. If you substitute 9 in for x, you'll see that you still get a true statement of 81 divided by 9 on both sides. However, if you substitute 0 in for x, what's the problem? Well, 0 in the denominator gives us what kind of answer? You should recall that this statement is undefined. It makes no logical sense to divide something up into 0 parts. So, what's the point to this? The point is that dividing by the variable is not a valid step because it eliminates a solution. Okay? Because what ends up happening is you convert x squared into x, which now means you're looking only or expecting only one answer when you really should have had 2 answers. Now, let's turn to the back. We have the following equation, and we want to first identify 3 different ways that we can solve it. Well, one way, which you saw in some of the homework problems, is I can distribute on both sides and then set the equation equal to 0. We're going to work through that. Clever students see that both sides have an x minus 2 times the other binomial, and they might say, I'm going to divide both sides by x minus 2. It's a clever suggestion. The third suggestion would be to take everything on the right side, it doesn't matter if it's right or left, but right side, and subtract it from the each side. So I'm going to subtract x minus 2 times x plus 5 from both sides. And then distribute. It's just in the opposite order of number 1. Okay? So let's do the first two. All right? So I want to distribute first, and then I want to set it equal to 0 and solve. So my equation, x minus 2 times 2x minus 3 equal to x minus 2 times x plus 5. Do the distributive property, 2x squared minus 3x minus 4x plus 6 is equal to x squared plus 5x minus 2x minus 10. Okay. Our next step, combine our like terms. Now, since you should notice, let me just scroll down so we have some room here, and then extend. All right, I'll readjust. Now, since I have x raised to the second power, I want to set this equal to 0. Well, it's easier to take this side and subtract it so that you'll see why in a moment. Whatever I do to the right side or one side, I have to do to the other. The benefit of going this direction is that if I decided to subtract this side from there, I would have been left with a negative x squared. Not the end of the world, but it makes life a little bit more difficult when I try to solve this. Now you should notice I have a nice trinomial. It's all set up to use the I am method. I set each one equal to 0, and I get my two solutions. Okay. Now, let's look at the second suggestion on how to solve this. And I'll just move this in case anybody's still looking, which was to eliminate x minus 2 from both sides, or divide both sides by x minus 2. So the suggestion is divide each side by x minus 2. Well, the thing that's really nice about it is it leaves me with a much simpler result. Okay? As you will see, the highest exponent of any of the variables is 1. That means it's a one-dimensional, or this is called a linear equation, which you should recall from last year. So solving linear equations, I want all the variables on one side, all the numbers on the other. So I will subtract x. You could do this via different steps. Add 3. Now I get x equals 8. Well, what's the problem with this strategy? This strategy is telling me there's only one answer, while we know there were two. What answer has disappeared here? The answer of 2. Why has that disappeared? Because if I substitute 2 in here, it makes the denominator 0, and algebra tells us that that's not valid, so it kicks it out as an answer. So what's the point? Dividing by a variable to solve a quadratic equation, which I'll define in a moment, is not a valid process. Okay. Now, let's just get to our definition, and then I want to give one other example. So a quadratic equation is an equation in the form ax squared plus bx plus c equals 0, where a cannot equal 0. Now, why can a not equal 0? Well, if you think about it, if a is 0, the x squared part disappears, and that leaves me with just bx plus c equals 0. That is a linear equation, as we just talked about. Okay, last part. Let's say I have the following two equations. I'm sorry, I want to change that. 10, 5. Make the numbers a little nicer. Well, how did someone or a student change this equation, the x minus 5 equals 5, to x minus 5 squared equals 25? What did they do? They squared each side. Let's see if that's a valid method. Okay. Well, to solve this, which is very straightforward, we get an answer of 10. So if I wanted to solve x minus 5 equals 5, I know my answer is 10. Remember, x minus 5 squared does not mean to distribute that exponent. It means to do the following. When I distribute, since this is a quadratic equation, I want to set it equal to 0. So I'm going to subtract 25 from both sides. Sorry, that's not a very good looking 25. I combined my like terms, so I did a couple things together here once. Now you should recognize I factor using the GCF. And now I get two answers. Well, I was only expecting one answer, but when I squared it, I got an additional answer. That's a problem. So the point, you cannot square the equation to solve because it adds an answer or solution. Okay? So today's lesson was just a continuation of what we've been learning on solving quadratics and what's a valid method of solving versus an invalid method of solving.